Welkom allemaal. Ik ben Paco van Beckhoven. Ik ben een full-stack developer bij Open Value. En ik ga jullie vandaag wat vertellen over hoe je je hoofd cool moet... I should do it in English, I think. So, sorry. So I'm going to talk to you about keeping your head cool with a serverless voice-controlled fan. With a cool demo at the end, I hope, if it all works. So, keeping your head cool with a serverless voice-controlled fan. So the idea started in at a hackathon we had last June in France, where I wanted to learn something about serverless. I wanted to do actually play with Raspberry Pi, and then more as in usually you have a Pi and then you create a media center or something. I wanted to do a bit more, like make a LED light up, still basic. And I wanted to build something for the Google Assistant. I have this nice Google Home Mini device, and I thought it was cool to make something my own. So I brought this all nicely together in the idea of a serverless voice-controlled fan, but of course actually this still needs a use case. So I'll first explain the use case. So we have a problem. The problem is you wake up in the middle of the night and it's very warm and you're sweaty, and then you want to turn on the fan, but it's like out of reach, or the remote of the fan, you just can't reach it, which is really annoying. So now you have two options, and the first option is to actually open your eyes, get out of bed, and turn the fan on, or, and that's of course what we're going for, is you're going to shout to the fan, and then it will turn on, which is even better. So what we want is from the Google Assistant to a very cool breeze. So what do we need for this? We have one of the important parts, of course, we need to be able to convert speech into actions. We need a fan. We have one here. We need something to control the fan. So I have a Raspberry Pi over here. And we need serverless to glue it all together with a nice buzzword. So that's always good. So then I'll first go into serverless. So this is a really high level overview. But the idea of serverless is that you can run code without having to manage or provision servers. And serverless comes in two tastes. You have backend as a service, which is, it kind of originates from the mobile application development, where you, for example, had shared state that you had to manage. So you had an application and you had a website, and you needed to, for example, keep track of your favorites or how far you were with reading. And usually you use solutions like Firebase, which is very popular, where you have a database that syncs between these things. And also other examples are authentication services, where you just manage your authentication somewhere else. That's a bit the idea of backend as a service. And what you also have is functions as a service, which is what now is becoming more popular. I think AWS Lambda kind of started it, and that's purely computational. So you just have a function. It can be as simple as a Java function, which it usually isn't, that you just run in the cloud and then you can execute it. And when building things serverless, you usually have a combination of BAS and FAS. They go hand in hand because you cannot build an application. You usually need a database or something to build an application, and then you can use the functions or the FAS to kind of glue it together at some business logic. So a bit of background for the serverless. And now the actual first step in the process of me controlling this fan with my voice is being able to convert speech into actions. So we have three tools for this. The first one is the Google Assistant, which is similar to Amazon's Alexa or the Apple Siri. We have the Actions on Google platform, which is a platform that allows you to extend the functionality of the Google Assistant, so creating your custom commands. You do this in the context of an application. So for me, I built an application called Serverless Fan. Their building is much more than clicked it together, but we'll get to that later. And there's Dialogflow. Dialogflow is a bit optional. It's a wrap around Google Actions on Google SDK, and it's all pretty neatly integrated. It provides a lot of functionality and test and publishing functionality in editors and clickable things. So this is the tagline that you can use to get through this chain. The Hey Google is what triggers the assistant. Then the Talk to Serverless Fan is what tells the Actions on Google platform that it should go to my application. And then from there on you have the actual command that we care about, switch fan on, that is sent to Dialogflow. And dialog flow works with the concept of an agent and intents. And intent is mapping between what a user says and what action the system should take. This it does this based on training phrases. So you provide a set of phrases that helps the agent to know that this is the intent it should invoke, and also how to extract parameters. Because when I will be saying turn fan on, I want to at my service where I'll be processing this data, I don't want to have to search for on or off. I just want to tell it, okay, you recognize on, then send it to me as the parameter on. You can do this by also passing a training phrase where you also mark parameters. So you say in the sentence switch fan on, if you just mark on, then it knows that this sentence is basically, it can extract the parameter on. And you can also mark parameters as required, for example. And if it is required and you don't specify it, so you just say switch fan, then it will turn on, or it will ask whether you would like to turn it on or off again. And the important part also is, of course, the intent provides a response, and it does this through fulfillment. Per agent or per application, you have you configure one fulfillment endpoint. And they have two options for this. The webhook, which is you can just provide the endpoint of a web service running directly on a Pi, but this is also usually a bit inconvenient as firewalls and IP addresses, and it doesn't always work. Plus, I wanted to use serverless, and this very nice about Dialogflow is that you immediately have an editor where your serverless function, where you can type it, and when it's also immediately deployed to Firebase. Because in this case, I am in the Firebase bubble of Google, so I'll be using Firebase functions, which looks like this. This is the blank thing you get. The export is kind of what tells the Firebase that is neatly integrates with Dialogflow, although I think there's in the back there's also a lot going on. Yes, so this is the idea of the function. What you see at the bottom is an intent map. Like I mentioned earlier, you can have multiple intents for one agent. So if I would implement switch light or turn up the volume or something else, then I have different intents, which I can register, and then I also I can handle them differently. In this case, I only have one, so this is more boiler template than that it's useful. And the most important part is the switch fan function here with the agent parameter. The agent parameter allows you to talk back. So when I give a command and then at one point it will end up here in the cloud in the switch fan function, and when it runs the agent.add call, it will on my phone say switching fan on or off. And the parameters are all provided in the callback. So you have this request body, the request that's sent to the server, which just contains all the important information of Dialogflow. So it contains the parameters, but it can also provide you context. So it knows, for example, if you one point started with switch fan on and you later you turn a light on and then you say turn it off, then from the context it knows that, okay, what was the last command you entered or you spoken, and then you can see, okay, it would probably be light. But of course we're now in the cloud, we're printing somewhere switching fan on, which still doesn't do the full job because this doesn't make the fan turn. We need to get back to the Pi. For this we'll be using the Firebase real-time database. I mentioned it earlier as well. You can just stream. You can stream database. You can subscribe to paths in your database. So what I will do here is Firebase is, because I'm in the whole Google Firebase bubble. The Firebase database is as easy as initializing a connection to the database and some dependencies, and then writing to a fan object with a state field that has a value on or off. And now I've written it in this nice real-time database, which I can also stream from. There's a lot of libraries out there, also for Node. So we're now already on the Pi. On the Pi, I run a Node script that will also connect to the Firebase database, because we're no longer in the Firebase bubble. We now need to provide credentials and URLs, which is not that exciting. And then it's as easy as, again, pointing to the database to a path, and then as soon as its state change occurs, it will print a function on the Pi. Still doesn't turn on the fan, so we are missing few steps, or actually one, which is controlling the fan. So the Raspberry Pi has this nice set of pins, which I always wondered where they were for. Now I know. There are many different types of pins. So for example, the red means 5-volt, which is output. You have GPIO ports, which stands for General Purpose Input Output, and they can be used to either output 3 volts when configured to do so, or you can read from it using sensors, or when you're plugging in sensors. And the others are, for example, ground, which you can use to complete the circuit. So I'll be using these 3, but the Raspberry Pi only outputs 5 volts, and this thing needs 230. So that's still not going to make it. This is where we use a relay for. It's your basic, I think, maybe you had it in high school. It's electrically operated switch, and it's you can compare it to cutting the wire of your fan and then putting a button in between. And then if you click the button, then the circuit is closed again, and then we'll go on. But now I can do it electrically, and a relay works with a magnet. As soon as it receives current, then the magnet will get the voltage, or the magnet will activate. It will close the circuit, and then we will have a fan going on. And if you turn it off, then or open the circuit again, it will turn off. So then this is the most simple part. There's a million libraries available, and there's a lot of libraries available for controlling these pins. In every language that you can think of that runs on the Pi has this library. For Node, I already found several. I picked the one that needed the least amount of lines. And this is also the pattern you see across all these libraries. Some have error handling and everything around it. I wasn't really interested in that for now. What you do is you set up a pin, because you can either use it for sensors, so to read, or you can use it to write, and that means voltage. So with low, it's off, and with high, it's on. So when you say RPA write, and the 40 is the number. So if I go back to here, it's a pin all the way at the bottom right. So I know that's the GPI port that I'll be using to turning it on and off. So to give a quick recap, we started at the Google Assistant. From there on, we told it to go to the Access to Google platform to start up my serverless fan application. As you'll hear maybe in the demo, is that as soon as you're in your own application, you can have a different voice. You can have a completely, sometimes it's a bit weird, but it's a different container. That's the idea behind it. It sends your commands to Dialogflow, which does the processing and extracts the turn parameter that I called it. It does the fulfillment, which stores it in Firebase in the real-time database, and from there on we're at the Pi at the Firebase client, and as soon as the state has changed, we use the GPIO port to turn it on. So the demo, and I hope this will work, because usually it has some problems with my pronunciation of words. Talk to serverless fan.
All right, getting the test version of serverless fan.
Greetings. Use turn fan on to start a breeze.
Turn fan on.
Keeping your head cool.
Turn fan off. This is the part where turn fan off.
Stop keeping your head cool.
So this was a short talk about how you can achieve this. Thank you.